Yeah, again, thanks for joining this Q&A session with me, this acoustics Q&A session, finishing off 2024, going into 2025. And so I'm just going to start with my first question here, which is from Jason. I don't know, Jason, are you in the chat? If you can let me know, that'd be great to see if you're actually here. Otherwise, obviously, this is also, it's being recorded as far as I understand. So it is going to be excellent. Good to see. So it's going to be on the channel, obviously, for those people who can't make it. But yeah, so Jason, you said, hi, Jesco, Merry Christmas. A belated Merry Christmas back to you. My current studio was built from the ground up, focusing on optimizing the room ratio and collaborating with the top acoustician throughout the process. I've invested in excellent monitoring, PSI audio, and incorporated the Trinnov room correction system, which I've used since 2013. Despite this arguably ideal setup, there are still compromises. My biggest challenge remains a null at around 121 hertz, likely caused by floor bounce or boundary interference. That is possible, likely, yeah. That said, I've adapted to the space and can still achieve great mixes and masters. Excellent, that's obviously what matters, that's what we're here for. I also understand that there's no such thing as a truly perfect room, also true. Yet the pursuit of acoustic excellence continues to be a passion and labor of love, yeah, and a rabbit hole that never ends. Fixing this null feels like the final frontier. When I have some spare time, my next step will be experimenting further with speaker placement. I'm curious about trying the phantom focus system to see if it can help reduce the null. Looking forward to your thoughts, and thank you for all the fantastic content you share. Best regards, Jason. Thank you, Jason, for that. Good question. So, yeah, so if the room is already pretty well treated, it is very likely, well, obviously, if you've got kind of standing waves under control already, it is very possible that it is the floor reflection or speaker boundary interference. So there's a couple of things you can do to check that. Obviously, a very simple test. Well, yeah, it's not as easy as you might think, because my first intuition would be move the speakers closer to the wall and see if that dip rises in frequency, goes up in frequency, right? Because obviously the closer the speaker is to the wall, the higher that in frequency that first cancellation is, the main cancellation is. But then as you're increasing the distance from the speaker to your ears, the floor reflection, that delta is going to decrease. And what is that going to do? So I'm getting a little lost here with this right now. But the thing is, obviously, these two can be, they will both shift in frequency. That's the main point, right? As you move the speaker. So probably the first thing that I do is see if it is a floor reflection. If you've got some spare insulation material flying around, you can obviously try and see if you can catch that somehow, just as part of as kind of a measurement test. That's one thing you could do, right? Is just to see if you can get rid of that dip through just some experimentation with placing some insulation material on the floor. Obviously, you need to make it deep enough so that it actually catches 121 hertz. But that basically means something like 6, 8, 10 inches of insulation material should be plenty if you just put that on the floor. So that's one thing. One other thing that you can check is if you get a peak in the energy time curve in the impulse response, right? Because a standard reflection, so speaker to ear reflection, will give you a peak in the measurement, because obviously that reflection arrives at the microphone, while a speaker boundary interference effect does not show up as a peak in the impulse response, because it's not a full reflection back to the ear or to the microphone, it's a reflection back to the speaker. And so that won't actually appear in the energy time curve. Yeah, so that's something that you can check as well. You can obviously put some insulation material behind the speaker and just kind of see if that, just put a big slab, hold it behind the speaker, see if that does something. So that's another test you can do. And what was the other thing I was just thinking of? Something else I wanted to say on that and to that. And Can't quite remember, but yeah. So that's kind of, those are the couple of things that you can test. The turn off shows the impulse response. I'll check that. There you go. Yeah. So that's something you can do. Yeah. And what was the thing? There's something else I wanted to say. Well, can't remember. If I remember, I'll let you know later on. Yeah. But I think that's definitely, those are some of the tests that you can do. Yeah. Keep in mind that not everything that appears in the frequency response necessarily needs to be fixed. Yeah. Now I remember what I wanted to say. If you haven't come across it, there's a program called Open Sound Meter that you can use to give you, it's free, first of all, and it gives you real-time FFT, basically, real-time energy time curve, real-time frequency response. And so you can have that running while actually moving stuff around and seeing if that changes stuff. Yeah. So that's actually what I wanted to say. Yeah. So that's the tool that I would use for this kind of testing, because it's so much quicker than using Trinov or using RubyQ Wizard or something like that. Yeah, to do these kind of tests. Yeah. So yeah, I hope that gives you something to work with. But yeah, good question, and yeah, fun project to get rid of that. Rid of that dips like that. Yeah, you're very welcome, Jason. So the next question is from Jean-Francois. I'm not sure if he's here. Maybe if you can just let me know. So he says, hi, Jesco, my room is quite small, 14 by 9 by 8 feet. My RT60 is 0.2 seconds from 20 kilohertz to 90 hertz. My frequency response is plus minus 3 dB from 20 hertz to 20 kilohertz. Depending on what smoothing that is, that's very good. Yeah, that's very, very good already. My issue is the reverberation at 86 hertz, about 0.4 seconds, and a few other spots lower. I already have 10 panels, 2 by 4 by 4 inches of rockboard 80 around my mixing spot, and 2 in the back, plus a 4 by 4 foot cloud on top of my mixing spot. I love how my spot feels, not too dead and not too live. It's really that lower frequency part that bothers me a bit. How would you tackle my issue? Am I aim for tuned membrane traps for that specific 86 hertz, or aim lower to kill the mode that might be stimulated? I use Lipinski L707 with upgraded A drivers and 2 sealed subs, positioned center front wall and center back wall. My mixing position is pretty much in the center of the room, which is the flattest I could get after days of measurement and experimentation. Thank you for your time. Wishing you a wonderful holiday period. Martel, sorry. That's how you signed it. Martel, maybe you can let me know if you're here. Yeah, it's a good question. I mean, I think you responded to my email yesterday as well, didn't you? First of all, you got to understand that if you're within plus minus 3 dB, 20 to 20 kilohertz, even with third octave smoothing, but even if, let's say, if it's 12 octave smoothing or even 24th, I mean, that's excellent already. Yeah, and I would at this point just not worry about it. This is my honest answer. Yeah, because 0.4 seconds is already very low. Yeah, so the thing as well is, like, you don't want to obsess too much about reverberation times, especially in treated rooms. Yeah, you got to understand that RT60 is a metric that is defined as basically sound coming from all directions with equal probability to a certain point in the room, right? And so in a small room, you don't have RT60 because that definition it is not fulfilled. Yeah, so we're not measuring RT60, we're measuring decay time, but it is directional and it is highly dependent on where you measure. And so, so RT60 as a metric isn't particularly useful in small rooms. Here's the other thing, that if you increase the absorption, if you put more absorption in the room, that situation, it becomes even worse. Yeah, so funnily enough, the more absorption you put in a room, the less of an RT60 you are actually measuring. Yeah, because the less homogeneous the sound field becomes. And so you end up with something that isn't anything, that doesn't resemble anything in terms of, like, it doesn't resemble a proper RT60 as it's defined at all. And so you can't really use any of the measurements, any of the models, any of the calculations that use RT60 as it is defined, because you're not actually measuring RT60. And so that's why, for example, maybe you've seen this in Ruby Q Wizard, that if you look at the RT60 tab, sometimes you get these huge jumps and that are seemingly out of nowhere, and they'll be in one measurement and they'll be gone in the next. And that's because the software can't handle the fact that it's not actually measuring RT60. So it's trying to apply maths to a number that doesn't represent what it actually assumes it is. Yeah. And so my recommendation really is to kind of step away, back off from looking too much at RT60, because it's not a particularly useful metric. Yeah. That said, it's a pretty small room. Yeah, I mean, it's not tiny, but it's not huge. Yeah, from an acoustics perspective, it is still a small room. And in these small rooms, space is at such a high premium that really the best you can do is work with porous absorption. Yeah, because even membrane traps, resonance absorbers, take way more space than you would expect to actually get a significant effect. Yeah, and you need, and since they're so narrow in terms of the frequency range that they're tackling, you're using up a lot of valuable space to attack or to deal with one single issue, when you need to look at, or when you need that space to tackle a way more broader amount of issues in the first place, right? So I would, if you really want to reduce the reverb time in the low frequencies more, I would look at increasing the depth of your existing panels, yeah, because 4 inches just isn't that deep yet. Yeah, and 4 inches for me at least is kind of right at the edge of what I would call not a bass trap. Yeah, basically, from my experience, 6 inches is the absolute minimum at which you could just about start calling it a bass trap. Yeah, anything beyond that actually starts properly absorbing absorbing bass. That's what she said. Yeah, yeah. So there's kind of the issue there. Yeah, if you want to get more low end absorption, you really want to have just deeper absorption for your existing panels. Yeah, so that's kind of my recommendation there. Yeah, and don't obsess too much about reverb times. It's not worth it. Yeah, but still, I totally understand it. I totally get it. And good question. Yeah, so let's move on. This one is from Jeremy. Jeremy, are you in the chat? Maybe you can just let me know. So Jeremy asks, how big a deal is Symmetry? Does a good studio need to be completely, dead acoustically? Okay, so these are pretty, well, the second one is almost philosophical, right? I mean, it's because you're asking about kind of about what works best in terms of translation. Yeah, I mean, obviously, the question that we're always asking is not, does a good studio need to be completely dead acoustically on its own, but for what purpose, right? For the purpose of mix translation, usually, right? And so in that sense, you kind of have to ask, what do you need from your room and your speakers for proper mix translation? And that isn't actually properly defined. There is no kind of defining or fully defining research on this matter. Yeah, so so all the acousticians up to now have kind of found their own path, their own solution to this question of, how do I make the room and the speakers translate properly? Yeah, and everybody's come up with their own kind of solution. But in the end, it always boils down to, how do I remove the impact the room has on the speakers while not making the room feel like an anechoic chamber to the person that's in it, right? That's kind of the quest that every studio acoustician has been on since they started building control rooms. Yeah, because you need to get rid of the effect of the room on the speakers to hear the speakers properly, and arguably the most reliable way to get your speakers, your mixes to translate, is to have speakers, is to be able to hear your speakers on their own without any extra effects on them, any extra distortion, any extra stuff, right? And so, does the room need to be dead completely? Yes, at least from a you being able to hear your speakers properly perspective. Yeah. But then on top of that, we have this question of, but is this still a room that we want to be in? Is this still a comfortable space to spend time in, to sit in for hours on end, right? And from that perspective, maybe not. Yeah. And so, I mean, that's why, for example, Northwood Acoustics, with their front to back approach, is basically two rooms in one. The speakers play into an anechoic chamber. The sound leaves the speakers and it never returns anywhere. It just kind of goes through the room and disappears, at least from the speaker's perspective. But from the user's perspective, there are some strategically placed reflections, aka diffusers, to give the person a sense of the space. Yeah, there's more to it than that. There's psychoacoustics to it that you can check out if you want to. Yeah, but so that's how what's his name? Can't remember his name right now, but that's how he solved that problem, right? So he found a way to separate the effect, the response of the room. He found a way to separate that in terms of what the speaker sees and what the user sees. Yeah, and that's what makes it very special, in my opinion, and very, it's kind of the most modern approach at this point, in my opinion. Yeah, but if you look at all the previous control room designs, right? So obviously starting way back with low end dead end. That's the room I want to be in. Live and dead end, but obviously non-environment and RFC rooms and whatever they're called, right? They all try and solve that same issue, but with a different approach. Yeah. Okay, so very long-winded answer, but maybe that gives you an insight into how I think about this. And in terms of the symmetry, well, yes, how big a deal is symmetry? It's one of the main important factors to be able to hear stereo properly, right? Two speakers, they basically have a mirrored response, or they ideally have a mirrored response, because that's what gives you a proper phantom center and a proper sound stage. And in order to get that mirrored response, everything around them needs to be symmetrical. Yeah. Obviously, in home studios, that's not always possible. And to be honest, most studios aren't perfectly symmetrical. Yeah. Usually there's symmetry around the speakers and the listening position, but then, you know, what happens in the back? I mean, you'll probably find that most professional studios don't sound that great. Yeah. And there's lots of stuff going on in there that you wouldn't expect. Yeah. But yeah, is symmetry important? Yes, at least local symmetry. That's my kind of requirement for it. Yeah. So if you're setting up your speakers, ideally your listening position or your listening setup, your mixing setup, you want to place it in a portion of the room, in a part of the room where you can get local symmetry. Yeah, because those early reflections is what make up the main component of that symmetrical response. All the stuff that happens a lot later isn't that important. It's lower down in volume. It comes later in terms of the response. Its impact just isn't that great. Yeah. So the further away from your speakers that asymmetry is, the less of an impact it will have, basically. Yeah. You said, glad to hear that dead rooms aren't bad for mixing, though. I might have doubled Feynman's landmass just with the rock wall alone. Exactly. Yeah. Okay. This next one is from Keith. Again, Keith, if you can let me know if you're in the chat, that'd be great. Keith says, hi, Jesco. Thanks for all the info so far. I've started building a home studio. My floor plan has been optimized as best as possible. I think it'll work well. My only question so far is, what is the impact of a window between the control room and the live room? The current design is to have a 3-foot by 5-foot window to the left of my control room sitting position, looking into the live room. All right, very close to the first reflection point. Any wisdom would be appreciated, Keith. Good question, Keith. I mean, so I don't know if you've seen one of the videos that I did on windows. At least I did at least one so far. I see windows pretty much like just a standard stretch of wall, just standard drywall, because in terms of the actual acoustic response, it's not that different. Yeah, so basically one layer of drywall and a sort of single paned window, they basically respond similarly. Yeah, they let most of the low end energy through, and then as you go higher up in energy in frequency, they start reflecting. Yeah, and so I don't see windows in any particular way. I just see a reflecting surface. And then the question just is, am I willing and able to treat that section of wall, aka the window, in the way that I need to treat it, depending on where it is in the room? Obviously, if it is at the first reflection point on your left, yeah, that's not ideal. But maybe you've seen some of the designs where they basically angle the window, right? So that reflection doesn't bounce back to the listening position. Yeah. And then so if you talking about symmetry, we just had it. So if you angle that window and you put absorption on the other wall, ideally in a way so it mimics the frequency content, how it is reflected. Yeah. So I guess in the case of the window, I mean, obviously you're trying to isolate as well. So there's a noise or like a sound isolation barrier there as well. So it won't reflect anything really, will it? So you're trying to do the same on the other side. That's what the point I'm trying to make, right? So symmetry in terms of reflection, you want a symmetrical response. So you want the other side to respond, behave in a very similar way. That's the goal, right? If you don't have an angled window, if it is fully reflective and just reflecting back to you, you might be better off keeping the other side fully reflective as well. Yeah, ideal? No, but symmetry in that sense, in that case, to me, is probably more important than getting rid of that early reflection. Yeah. So yeah, I hope that answers that question. I'm just going to take one more here from the list, and then I'm going to check out the chat. If you have any questions already for me in the chat, drop them in now so I can get to them in a second. So this next one is by Mike. Again, Mike, let me know if you're in the chat. Mike says, "Hi, Jesco. Thanks to your content. I already built a well-treated studio. Sweet. Very dry room, but that's what we're going for. Indeed it is. Great bass response. My question, I have a measurement mic with both 90 and 0 degrees calibration files. In SonarWorks, only one calibration file can be selected, but the measurement process involves both 90-degree and 0-degree angles. All right, that's news to me. Which calibration file should I use? Could SonarWorks be using 90 degrees for frequency response and 0 degrees for phase time differences, or vice versa? Kind regards, Mike. Yeah, interesting question. And Keith says, thanks, Jesco, very helpful based on your feedback. I have a plan. Excellent. Good, Keith. Glad to hear it. But back to Mike. Yeah, it's a good question, and I'm not surprised that you're confused. So this thing with 90-degree and 0-degree, well, whichever is which, calibration files is a question of the type of microphone, usually. Yeah, that's why I was a little surprised to hear you say that in SonarWorks, the measurement process involves both 90-degree and 0-degree angles. I haven't done a SonarWorks measurement process in a while, but the last time I did it, that was not the case. So I'm a little surprised here. So maybe just double check that first of all. Yeah, because I would be very surprised if that's actually the case, because this whole 90-degree and 0-degree angle thing, calibration file, is about actually basically the frequency response of the microphone. There are microphones that are calibrated to basically point at the source and then be at 90 degrees to the source. Yeah. What's it called again? They're basically is it free field? Maybe somebody who knows in the chat, maybe you can let me know. Is it free field? What's it called? Freifeld in German. Freifeld entfernt, Diffusfeld entzerrt. It's basically about how the microphone picks up the high end. Yeah. So if you have a measurement microphone, if you get your cheap ass Behringer ECM 8000, yeah, you can point it like this, take a measurement, and then point it like this, and then with obviously the tip being at the same point, and then take another measurement, and you'll see that the high end changes. Yeah, there's basically a dip. The high end drops off in one of the measurements. Yeah, and that tells you which of the two types of microphone this one is. Yeah, again, I haven't looked at this. This is so, like, to me, this is so not important. Yeah, as long as you're consistent, that's the important bit. Yeah, so pick one, pick this orientation, or pick this orientation and stick to it. Yeah, the reason it's not important, to me at least, is because I don't need absolute perfect high-end data. Yeah, obviously the 90 degrees file could be used with REW and then point the mic at the ceiling. Yeah, so as long as you're consistent, and the reason I don't care is because I am very much of the opinion that you want to tune your high end by ear. Yeah, so the actual curve in the top end does not matter. Yeah, as long as it's more or less in the ballpark, yeah, that's fine. The rest, like, that means that the speaker is behaving properly. Yeah, it's not broken. That's what is important. Yeah, usually there's nothing crazy or nothing really important in terms of room acoustics happening beyond kind of, I don't know, 8 or 10 kilohertz. Like, everything up there is just, it doesn't matter. Yeah, so and that's where that difference appears, right? And so I don't really care. Yeah, I need consistent data. That's what makes it comparable. Yeah, and that's what also is going to show me if something's broke, right? And then once everything is kind of where it needs to be, I do the tuning of the high end by ear. That's because you're so sensitive to how the high end sounds that you want to do that by ear anyway. Like, if it's too bright, you'll want to take it down a notch. If it's too dull, you want to brighten it up a notch, no matter what the measurements say. Yeah. And so, yeah, I don't really care about this long-winded answer. So first of all, check whether SonarWorks actually really needs both angles. I'd be very surprised if it does. Yeah. And then maybe read up on, I wish I could tell you what it's called in English. Diffuse field. It's called either free field or diffuse field omnidirectional microphones. When using SonarWorks, they use the 0 degrees file by default, and you should follow the instructions. Yeah, I've always used the SonarWorks mic with Dirac using the 90 degrees file. Okay. But yeah, so it's a consistency thing. Yeah. But any case, Mike, yeah, totally get your question. Double check that, and I'm sure you'll figure it out. Yeah, it shouldn't be that difficult. So let me jump into the chat here. Got some questions in already. So what do we got? Steve Zipper, I've built a good sounding room, but I have a sizable peak at around 125 hertz. When I EQ the bump out, the material sounds thin. Room sounds better with the bump. Room is 14 by 10 by 9. Well, then leave it in. I mean, we gotta always remember that what we're trying to do here is art, as in mixing is art, and the sound that you get needs to support that process. Whatever that stupid measurement says, yeah, it doesn't matter if your mixing works, if you can judge what you're hearing properly. That's the ultimate question that you need to answer, not whether there's some peak in my measurement. Yeah. Obviously, still, I get that it's annoying to see. So you might want to take care of that. I mean, it's, to be honest, 125 hertz peak is probably a room mode. Yeah. And if you're trying to EQ that, you like, if it's purely a room mode, you can't really EQ that properly. Yeah. It's worth trying because a lot of times there are effects stacked on top of each other. Yeah. And so some of those you might be able to actually EQ, while others you might not be. But if it's a pure standing wave, you can't actually EQ that properly because you're just basically adjusting how much energy you put into the resonance system. Yeah. Excuse me. And so you can get some really crazy effects when you're trying to EQ room modes. Yeah, it's also, you really have to hit the frequency perfectly, which means you need to measure perfectly. Yeah, and if you look at the windowing aspect of actually of separating out the valid data of the measurements by windowing, you'll see that that comes with a frequency resolution penalty. Yeah, so you might only be able to actually be to tell down to about 5 hertz where that peak actually sits. Yeah, so it might tell you that it's 125 hertz, but actually it's 121. Yeah, and so that can be a problem. Yeah, but yeah, I mean, room sounds better with the bump. Leave it in. Yeah, I'm definitely, I don't need a flat frequency response for sure. Yeah, but yeah, Steve, let's see, let's move on. Danielle Zandera says, hi. Hey, Danielle. What about to fine tune the speakers according to your own ear response? I know my ear doesn't work in the same way. I'm all about toning the system by ear. Yeah, so you can see this. You can kind of separate out two aspects of this, what we traditionally throw together as tuning. Yeah, but the sound system people, they separate tuning and toning. Tuning is making sure that the system technically behaves as it's supposed to. That doesn't mean it sounds good. It just means everything is set up correctly. But it may still sound like crap. Yeah, but it works as it's supposed to. And then you can do the toning, which is actually adjusting it to how you want it to sound. Yeah. So one way to imagine this is, well, when I did the seminars with Merlin Van Veen, he always talked about the pizza delivery guy. Yeah. So tuning the system, a perfectly tuned system, is the pizza that you ordered arriving by the guy on the moped from his little trolley thing in the back of his moped. Basically in the exact same way as it came out of the oven. Yeah. So the transmission of the pizza did not alter the pizza in any way. It's exactly the same as it came out of the oven. Obviously, it might still be a shitty pizza and you don't like it. Yeah, there might be olives on it that you don't like. Yeah, so then you pick off the olives, and that's the toning. If that makes sense. Yeah. So in terms of the acoustic response, you can tune the system to respond perfectly. Right, so there are no mistakes, technical mistakes in the acoustic response. It might still sound like shit, but it works perfectly. And then on top of that, you can actually do some toning, and that is shaping it to how you'd like it to sound. Yeah, so I definitely recommend that you do that, because we all have different tastes in terms of low end and high end in particular. Yeah, so if you're, and again, maybe you saw my last video, your mixes will actually tell you what you need to do. If you're consistently making the same mistakes, especially in terms of balancing overall amount of high end, overall amount of low end, if that's a consistent mistake, excuse me, yeah, then that's a sign that you need to tone your system differently. You need to add in some bass, get rid of some bass, add in some high end, get rid of some high end, so it closer matches what you actually inherently want to hear. And that will allow you to work more intuitively. Yeah. So that's kind of that's kind of the that fine-tuning speakers question, if you will. Yeah. So Danielle, good question. Let's see again here. Moving on. What else have we got? Whoop, massive jump here. By the way, awesome to see you guys. It's great to have you joining, all of you watching. Here's one. I hope I didn't miss anybody. Stelios says, hi, how can I measure where to place my ceiling treatment? The room is 3 meters tall. I don't recommend you measure, at least if we're talking about acoustic measurements. I recommend you do this also off of first principles. Yeah. So just analyze the reflection pattern. If you look at a side view of the room, a cross section, if you will, right? Here's your speaker. This is your speaker. Here's your microphone. And let's say the top of this image is the reflection. Obviously, this is just like a mirror point reflection when we're talking about the sidewalls. Yeah. So sound emanates from the speakers and bounces back to the microphone. Where does the ceiling treatment need to go? Right there. Yeah. So it's similar process. You got to remember, there's nothing special about the ceiling. The ceiling is just another surface, as is the sidewall, as is the front wall, as is the back wall. Yeah. The thing that makes it slightly differently is that the speaker is directional in terms of how it plays sound. So certain surfaces won't receive the same frequency content because of the directionality of the speakers, right? Especially, obviously, the wall behind the speaker, your front wall, doesn't really get any high frequency information from the speakers because high frequencies are directional towards the front. Yeah, but the ceiling very much still gets full spectrum sound from the speaker, and it's just another reflecting surface. Yeah, the ceiling cloud is just another reflection absorber. Obviously, it can do double duty in terms of low frequency absorption. If you make it deep enough, it will also do low frequency absorption on top of just stopping that reflection or absorbing that reflection. Yeah, and so you can actually use it for both. If you have the available space to put enough deep absorption on the ceiling, you can get some significant low end absorption under the ceiling. Yeah, so that's how I do that. And I mean, you said your room is 3 meters tall, Stelios. Yeah, so put half a meter of absorption up there. Yeah, the entire ceiling. Go for it. Yeah, get one gigantic bass trap under the ceiling. Yeah, works wonders. I'll swap my null for Steve's peak. Yeah, I wish we could do that. So Jay King asked, I'm a voice actor and I'm dealing with some reverb. I have some acoustic foam panels and the walls covered in moving blankets, 6x4 inch space. Yeah, so the thing with the voice obviously is that doesn't really involve low frequencies. Yeah, so that the big advantage with recording or voice over recording rooms is that you don't need to make the absorption as deep. You don't need any bass trapping, basically. You need low, mid, and upwards absorption, basically, right? I mean, upwards of 100 hertz, basically. Yeah, and means you can get away with, equation is how much in terms of frequency am I absorbing, aka how deep is my absorption, and how much surface area am I covering with that, right? That is the basic equation of acoustics. What's the frequency content that I'm absorbing, aka how deep is my absorber, and how much surface area am I covering? Yeah, and that's kind of the second one is what people kind of make or fall into the trap of assuming too much from both, yeah, or too little, whatever. But you basically need a substantial amount of surface area covered with a substantial amount of depth, and then you'll get the acoustic effect. Yeah, and so in terms of voiceover work, you can. The great thing is that you can stick to about 4 inches, 10 centimeters of absorption on the wall. That'll get you down to about 100 hertz, roughly speaking. Yeah, and at that point, it just becomes a question of how much surface area do you cover, and that is, in my opinion, probably if you really want a fully proper dry recording, you need to cover the entire room. Yeah, it's as simple as that. Yeah, but if it's a small space, yeah, again, the entire room, or just start experimenting. Put in more and more panels and see what the space sounds like on the recording, and that'll tell you if you need more. Yeah, you will get it to being completely dead or completely dry if you just cover everything. Yeah? So the question is just how far in terms of that process or in terms of coverage do you go? Yeah. So good question still. I totally get it. Hans Twite says, hey there, I wanted to thank you for your generosity in sharing all this info. You're very welcome. I was just visiting your channel again as I'm building panels this weekend and trust your methodology. Keep at it. Good to hear it. Let's see. Oh, there's lots of stuff here. Where am I? Stilio says, do you think 2-inch panels will work for ceiling, or are they very thin? To do what? You always have to ask 2 inches to do what? 2 inches will absorb perfectly in terms of high mids and high frequencies. But if you want low frequency absorption or low mid, you got to go further than 2 inches. Yeah. If you haven't checked the Porous absorber calculator, if you literally just Google Porous absorber calculator, and that'll come up, and you can check what 2 inches of insulation material will do on the wall. Yeah, and if that reaches down low enough. But again, in my opinion, 6 inches insulation material, it's like this much, and more, is just enough, is at the very edge of what I would start calling a bass trap, if you also then place it in a way that you have a proper air gap behind it. So another 10 inches of air behind it. Yeah, so 10 inches air, 6 inches of insulation material. Yeah, we're already stretching the limit of what I recommend for an air gap. Yeah, because you want that 1-to-1 ratio. Air gap needs to be the same size, maximum, at a maximum the same size as the insulation material core. Yeah, but 10 inches air, 6, 8, 10 inches of insulation material, and now we're talking proper bass trapping. Yeah, and then again, how much surface area are you covering? Yeah, so obviously you won't get any proper bass absorption if you put a piece of insulation material this size, a cube of this size, 10 inches away from your wall. That won't do anything. Yeah. All right. Chase West says, what do you think about the soffit bass trap GIK offers, especially compared to putting a thick panel in the corner? They're great. Yeah, so GIK is one of the few companies whose products pretty much do exactly what they say. Yeah, the question isn't really the question is, and is this the right tool to do the job? Yeah, the soffit trap works great as far as I understand. I haven't used it myself, but it is yeah, it works great. How is it different to putting a thick panel in the corner? It isn't. Yeah, because again, the basic fundamental equation of acoustics is how much, or what frequency content are you absorbing, and how much surface area are you covering? Yeah, and so the difference between a panel and a square soffit thing that you put in the corner is mainly a question of a little extra or less surface area. If the absorption coefficient is there, so what frequencies you're absorbing, if that's the same, they will perform the same. Yeah, the shape doesn't really matter all that much. Yeah, people get really confused about this whole shape thing. The shape thing doesn't matter. Yeah, what matters is the absorption coefficient and how much surface area you're covering. Yeah, it can be whatever shape. Yeah, that's why I don't care about tube traps very much. People get really defensive when I say tube traps aren't anything special. Yeah, but they're not. It's just insulation material in a different shape. Yeah, and they somehow offer a slightly different approach to how you define the surface area, maybe. Yeah, but that's it. Yeah. So anyway, GIK, great company as far as I know, great products. Yeah, I think their monster bass trap is great. The soffit trap, I again haven't tried it, but as far as I understand, it works great. Yeah. Frederick asks, I have a 5.2 home studio, 4.5 meters wide, 9 meters long, only 2 meters high. Overall, succeeded at treating the room well. Mixes translate well in big theaters. one issue I still... the issue is that for some high frequency sounds like birds or insects, I don't know if they come from front or back speakers. Okay, I wish I could help you with that. I have to say my experience with surround sound systems is basically nil. So I don't really know what to tell you here. Yeah, wish I could help you. I don't know. I bet there's somebody out there who has more experience with this, with surround sound systems. I mean, it's obviously a very high frequency thing. Don't know. Sorry, I wish I could help. What about the PSI AVA's magic weapon under 150 hertz? Haha. So obviously I've hinted at this. I'm in a very extensive testing process. So I've got 2 of them and I've been dragging them from studio to studio. I've measured them in 6 studios so far. My plan is to get to 10. And so you can definitely expect this year for the most ultimate, best, most extensive, final nail in the coffin review of the PSI AVAs. To give you a first glimpse, they work. They are fairly expensive for what they do. So it's a question of whether this is worth it to you. And they definitely work best so far, as I've seen so far. They work best in rooms that don't have any low-end treatment yet. Okay, so for those who can afford it, it looks like the verdict is going to be something like, excuse me, the verdict is going to be something like, for those who can afford it in rooms that don't have space or you don't want any deep absorption in there, so you can do a combination of AVAs and some high frequency absorption to do some very basic reflection control. Yeah, but it is very expensive. That's my first, those are my impressions right now. That might still change. Yeah, so don't take my word for it just yet. Wait for the final review. As far as I can tell, or as my plan is to both have the measurement data and a qualitative assessment. So everybody who's testing them has to do a little review, answer a few questions. So there's both the data, and then you'll also have the impressions that people have while using them for about a month in their studio. Yeah, it's a very interesting product. Very interesting product. All right, so let me just jump back to the questions from that were submitted before. One is by Dennis. Dennis, I'm not sure if you're in the chat. I've seen where some people, myself included, have studios in a basement or building where there is no finished ceiling. Instead, you look up and see the joists and the bottom of the floor above. Would you treat this overhead surface the same as a finished ceiling or do something different? Seems to me the joists might act like some kind of comb filter by introducing lots of reflections. Or maybe instead it's a great diffusion system. Wondering what you think. It's neither, Dennis. Comb filtering is a frequency effect, not a geometrical effect. Yeah, so comb filtering happens in the frequency response, which is a secondary effect in the time domain caused by interference between 2 coherent sound wavefronts, basically. Yeah, so it's definitely, forget about comb filtering. Yeah, that has nothing to do here. Will it introduce lots of reflections? Probably not. Yeah, so you got to remember, sound sees objects that are within the size, the dimensions of its wavelength. So if you're looking at joists, 2x4 beams, the largest kind of section the sound wave sees is going to be 4 inches. Am I getting that right? Yeah. And so the wavelength that sees this joist, this beam, is 4 inches or shorter. And we're talking very high frequencies, And everything below that in terms of frequency doesn't even see the beam. It just doesn't care. It's too small. Yeah. And so will you get some reflections? Maybe, but in the very high end. Is it a diffusion system? Definitely not. Yeah, it will somehow break up a certain frequency range, but it's probably going to be very narrow. I wouldn't rely on it. Here's my take on it. If you see a ceiling like that, use the space between the joists for an air gap. Yeah, so put a layer of insulation material underneath, and then you can also cover that with fabric. Yeah, so you put 6 to 8 inches of insulation material underneath, cover that with fabric. You basically build a frame, a wood frame that holds the insulation material, holds the fabric, and then you have an excellent bass trap up there. Yeah, so you make the space that the joists create part of the air gap. Right? Simple answer. Yeah. And nothing more complicated needs to happen up there. Larry says, hey, Jesse. But I'd prefer if you just call me Jesco. I've been preparing my new music room studio and watched a lot of your videos. Sweet, glad to hear it. I'm almost at the phase of doing acoustic treatment and lighting. I've been sifting through many possibilities in my mind. My latest thought is maybe I should do a full front wall of 6 inches plus absorption, but panels that would be pretty expensive for a large wall, 18 feet wide. My latest thought is just doing a whole wall of exposed insulation, the kind you'd put between studs. I've seen stuff about limp bag traps or holding them up by framing studs, and then they'd stay up with friction. I don't see much content on YouTube about the specific solution to room modes. I'd love to hear your thoughts about it and if you have any suggestions. Larry, you're basically talking about just doing a fixed install of acoustics instead of using panels. Yeah. The reason you haven't seen, well, I'm not sure why you haven't seen much on YouTube, because there is plenty on YouTube actually. Limp bag traps, not too sure what exactly you're referring to, but basically building a stud work that holds the insulation material in place, 6 inches plus, and then having some air behind it. Again, remember, again, like I said before, the basic equation is what frequencies are you absorbing, aka absorption coefficient, aka how deep is your insulation material, and then surface area covered. And you need way more than you'd think. 18-foot wide wall is a large wall, but that means it's a large room. You probably need way more than that. Yeah, if you want full control of the room, that is, obviously. Yeah, again, this is obviously, you're always asking, also asking, like, well, what is it you're trying to achieve? Yeah, do you want to just tame the reverb a little bit? Yeah, and obviously you can just put on some panels and you'll be happy. Yeah, but if you want proper bass control, we're talking a large quantity of insulation material, big, like proper depth, large amount of surface area covered. Yeah. But yeah, I think this is a good idea, as if I understand what you're saying. Just doing the whole wall with exposed insulation, putting some fabric in front. It's basically one gigantic absorber panel. Definitely works. It's basically how pros do the studios. See, go on the Northwood Acoustics side. Anybody listen, watching this, if you haven't been, go on the Northwood Acoustics website and go to the projects page and check out, or like the on the job page, and check out what that room looks like, what those rooms look like as they're building them, how much insulation material goes in there. Yeah, it's not often that you see how this is done, and you get a very good idea of at what this looks like if it's done at the most professional level that you can really get at the moment. Yeah. Anyway, Larry, good question. The next one is by, well, Stereotactic Music. I'm not sure what your name is, but I'll just go with that. I have a 3x4 meter room with the head type 30 MK2s. Should I downgrade to a smaller speaker? Would I get a better frequency response? This is a slightly convoluted question. A 3x4 meter room is not a big room, and a head type 30 MK2 is a very wide speaker. Yeah, I did a video on this at some point. I can't remember exactly what it's called, but maybe was it speaker size and room size. Maybe it's that one. I can't remember. The point is, what matters more than anything is to place your speakers in a way that you get a proper stereo soundstage and a proper phantom center. If you don't have a proper phantom center, if you don't have a proper soundstage, you cannot work, period. Yeah. So that is the most important thing when you're setting up your speakers. Everything else is secondary. Low end is secondary, frequency response is secondary, reverb is secondary, everything is secondary to having a proper stereo image, because you cannot work if you don't have a proper stereo image. You can't judge anything if you don't have a proper stereo image. You can work around a funky frequency response. You can work around not having proper low end. It's slightly trickier working around a very verby room, but it can be done. But you cannot work around not having a stereo soundstage. And in that sense, if you're not getting that's the thing you should check. That's what I'm getting at. That's the thing you should check. Are you getting a proper stereo soundstage with your head type 30s? If you are, great. Then obviously you could downgrade to a similar different speaker, but will that change much? Probably not. Yeah, because your setup is already good. Yeah. If you want to improve the frequency response, you probably want to look at acoustic treatment and some sort of speaker calibration. Yeah, because especially in a small room, you usually have to do both, because we can't get to a frequency response that is good enough just by using treatment. So you want to use both. You want to do as much as you possibly can with the acoustic treatment, and then add calibration on top, because you don't want the calibration to do more than it absolutely needs to. Yeah. So should you downgrade? Well, first check whether you have a proper soundstage, stereo soundstage. Again, if you haven't seen that yet, there's a free course on my website called the Phantom Speaker Test, and that's a step-by-step process to guide you through checking that using music. Yeah, it's a very simple process. You just got to understand what it is you're listening out for. Yeah, but yeah, good question. Let me take one. Let me just see. 1, 2, 3, 4, 5. Let me take two more here from the list. This one is from Alexander. I thought I may have seen you in the chat. Maybe not. All right. Alexander says, "Dear Jesco, I have a question on my mind. I've had a question on my mind for a while regarding the most crucial aspects of room treatment. When going through the process of modal analysis, you typically use the room's original dimensions. For example, 3.5 by 4.6 by 2.8. Subsequently, if you decide to treat the room with Helmholtz absorbers that are 25 to 30 centimeters thick and install them either as panels, covering over 60% of the wall ceiling or across entire walls, constructing a full structure, this would effectively reduce the room's dimensions by approximately 50 to 60 centimeters on the walls or 25 to 30 centimeters on the ceiling. This adjustment would theoretically change the modal calculations and could lead to errors if you are targeting specific frequencies, especially axial modes. In this post-treatment dimensions, am I right in thinking this? Yes, you are. You've come across a very important, as part of the process of making resonance absorbers work. And additionally, if the treatment is done with porous absorbers instead of Helmholtz resonators, would the same conclusions still apply? The same effect happens with, the funny thing is, with porous absorption, the room size, the apparent room size actually increases. That's why you see, if you put a lot of porous absorption into a room, the room modes will actually shift down in frequency because they're seeing a bigger room. The great thing, obviously, with porous absorption is they are not targeted absorbers in terms of frequency. They basically, whether that room mode sits at, I don't know, 68 hertz or 60 hertz, the porous absorber doesn't care. It'll absorb both. Yeah, so that's why one of the many reasons why I say work with porous absorbers and not resonance absorbers. He says, as a follow-up question, when treating a room for low frequencies, which frequencies would you prioritize targeting? The first axial modes are those that fall in within your sweet spot. Thank you in advance for considering my questions. I'd be grateful for insights you could share. Best, Alexander. I never recommend just treating for low frequencies. Because again, in small rooms, you don't have the luxury of just treating for low frequencies. You need to use a tool that does low frequencies, but does all the other stuff as well. Yeah, because space is at such a premium. Yeah, and so I don't recommend targeting any low-end frequencies. I recommend using broadband absorption so that you can tackle and absorb damp standing waves no matter what frequency they show up at, obviously down to a certain threshold. Yeah, I mean, it's very hard to really absorb 20 hertz with porous absorption. But in terms of which I prioritize targeting, the first axial modes or those that fall within your sweet spot. I mean, axial modes fall within the sweet spot. I'm not entirely sure what you mean there. All room modes also appear at the sweet spot, because room modes, they just potentially show a different part of their kind of energy game, if you will, yeah, depending on where you are in the room. But they will always, all room modes appear at all spots in the room. They just show up with varying energy, yeah. But yeah, the problem with Helmholtz resonators and what you're saying with the room getting smaller, that is a serious issue. And it's one of the problems that people have and that a lot of people stumble over and then also unfortunately fail at. Yeah, because you need to tune the Helmholtz resonator because the response of the room changes once you put them in the room. Yeah, that's the reality of it. Yeah, so I don't recommend doing Helmholtz resonators. Yeah, it's too hard. It's too hard. If you want reliable results, do stuff that gives you reliable results. Yeah, and you don't need Helmholtz resonators. You can do a lot with porous absorption. Yeah, obviously there are limits, and if you want the best of the best, then you need to work with resonance absorption. But then I don't recommend that you do it yourself. Then I recommend you hire somebody who has proper experience with it as well. Yeah. One more here from Pete. Hi, Jesco. The biggest thing holding me back is choosing the right absorption materials. Do you know of any low density insulation available in the UK suitable for 20 centimeter thick traps? RWA 45 is 45 kilograms per meter cubed. Seems the best you can get, and that is still way more than I'd want. You can get lower if you are prepared to experiment with materials such as polyester or wood fiber, such as Stykoflex 036. Declared level of airflow resistance is over 5 kilopascal seconds per meter cubed. I read that polyester and other various materials can be worse for health than stone fiberglass insulation, though. Some say the porous absorber calculator isn't very accurate, and the density doesn't matter that much in the real world as long as it's not ridiculously dense. I'm talking 5,000 Pascal seconds versus 15,000. Some people say flow resistivity is not a good way to measure absorption. I'm confused and unsure what to get. I don't want to waste my time and money buying the wrong material. Thanks, Pete. Yeah, Pete, I feel you. And my response is don't obsess about the insulation material density. Yeah. The thing that matters is absorption coefficient times surface area covered. Yeah. So what you want to worry about is, are you roughly getting the absorption coefficient that you want, which is a depth question, not a material density question. And then how many of those motherfuckers can you put in your room? That's the question you want to answer, because that's what's going to move the needle, not optimizing between 30 kilograms per meter cubed and 45 kilograms per meter cubed. Yeah. So yes, if you want something less dense, if you can find something, use something less dense for 20 centimeters. That's at the top end, but it will still work. And then Think about how many of those you can put in your room. That's the important question. Okay. But I totally get it. And the honest answer is, in terms of health, first of all, let me just, I mean, I made a video about this. This whole health debate is, this stuff is not going to cause you any health issues. Yeah, there's, if you, I can't be bothered going down this rabbit hole anymore because it's been done to death. Yeah, you can find out if you look for, there's a thread on Gear Space with a ton of links to the research about this, and ultimately the conclusion is it's not a health risk. Yeah, if you want to make sure that, if you want to make absolutely sure, wrap it in very thin plastic sheet, and a very thin plastic sheet, your cores, or cover it, yeah, with a very thin plastic sheet before you wrap it in fabric or cover it with fabric. Yeah, then the fibers won't be able to escape. And no, the plastic sheet will not do any harmful things to the absorption. It's too thin. Yeah, but then it can't be a problem. Yeah, I have, with all the people that I've worked with, I've had one person who's had a problem with this, and you won't even believe what he did. So he had, this guy's in Italy, super friendly guy, and he's completely aware of the error that he made. Yeah, but he built this panel. He did not wrap it in plastic. He didn't wrap it at all, I believe. He just, like, I think he stapled some fabric on the top, and then he put it in front of the AC unit. So the AC unit was literally blowing blowing air through the absorber in his face for years. And yes, he inhaled a lot of those fibers. Imagine why. And yes, it caused him some problems. He was also a very heavy smoker. Yeah. But apart from that, I've not heard a single person complain about this ever. Yeah. It is not an issue. Don't worry about it. Health is not an issue. Don't worry about it. Yeah. There are other things that are more important to think about. Yeah. But yeah, Pete, to kind of go full circle, think about, pick something and then just move forward. Yeah, it's not worth obsessing about it. You can't really get proper answers anyway. Yeah. But yeah, let me jump back into the chat here. How are you guys doing? Is everybody doing all right? Is people's heads already smoking? Let me see if I can find some more questions here. What am I looking at? Where am I? Where did I leave? What was the last question? Okay. Oh, Made in Machines. Is that you? Is that you, Pete? I believe. So metric, please. Nico, you sent some questions regarding subwoofer placement. I'll get to that. That's fine. No, it's not off topic. Anything goes. I'll get to that in a second. Somebody said, L says, I have obtained the best results with limp mass membrane traps with MLV membranes. 23 centimeter will get down from 55 hertz to 90 hertz. Get up from 55 to 90 hertz with a central frequency of 70 hertz without over-absorbing mids. Ever tried it? I have not. I thought that's something I want to try. It's a good point, though. It's definitely on my bucket list of a lot of things that I want to try. But yeah, working with limp mass membranes is definitely something I want to try as well, just because it's so easy, right? If it works, and I mean, you got to understand, with a lot of the stuff that I test or that I want to test, the only way it's really valuable is if I can find a way to test it where different types of material, different densities, different sizes don't destroy the result. Yeah, because obviously a lot of you guys, you're all over the place, right? You're all over the world. And I can't tell you to get this one particular product because it might not be available for 95% of the people I'm talking to. And so I'm always thinking when I'm thinking about testing stuff, ideas, things that I want to try, I'm always thinking about, is this resilient to changes in material? And how do I test for different types of materials to see if the results remain predictable and consistent? Because obviously, yeah, if I can't come up with a course, for example, on building membrane traps, if for most people it just won't work. Yeah. And so, but yeah, so limb mass membranes is something that I want to get to. Unfortunately, there's not much science on it. I need to talk to a physicist. There's not much kind of science in the acoustic space on it. What else have we got? Yeah, GIK use Knauf earthwool. Yeah, I think it's because of the glue. Hellfire Yoga, curious if Jesco's worked with DBX OmniRack 260. Not in a studio, but for sound system, yes. Recycled DEM insulation. So you got to understand this thing. The thing with non-mineral wool products. Yeah. So anything that isn't rock wool or fiberglass, glass fiber, whatever you want to call it. The relationship between gas flow resistivity, which is what we're mostly looking at to determine the absorption coefficient, the relationship between gas flow resistivity and the unit weight. So, for example, you said 20 kilograms per meter cubed. That relationship isn't given with other materials. So you can't use that same simplification in order to pick your materials when it comes to non-mineral wool products, which is why I recommend you stick to mineral wool products if you can, unless you have very good reasons not to. Yeah, because unless you know that the product works, because enough people have tried it, there's no way to tell. Yeah. So I mean, obviously, you feel free to experiment, but I want to pass on advice that is as reliable as possible. Yeah. So that if you do what I say, chances are very high that it'll work. Yeah. And with non-mineral wool products, that's usually not the case. Not to say that there aren't some that work great. Yeah. But again, most of them won't be available to many. Yeah, so I don't recommend them. That's why I don't recommend them. Yeah, because I don't know if they'll be available to you, and if I want to pass on reliable advice, then I need to stick to what works. So Rod says, hello, Jesco. Hey, Rod. Have you heard about the active carbon sound absorber technology? I know exactly who you're talking about. Apparently, it absorbs a lot of low frequencies in limited space panels. Quite heavy and expensive, though. Nice channel. Thank you. Have a look at their measurement data is all I'm going to say. Yeah. And you'll be surprised. Not to say that activated carbon isn't a thing, as far as I understand. Does it work as part of their products? That's a different question. Do you have an idea of why I find it so hard to find a consistent subwoofer level? I find myself turning it up on metal songs to have a full sound by getting knocked out by the sound from modern 808 bass. Very likely because you don't have a balanced low end at your listening position. Yeah. So depending on which room mode gets triggered, gets energized, if you will, by the particular music that you're playing, it'll deliver a lot of energy at your listening position. Or if a different room mode is triggered, none at all. And that means that you aren't located, your listening position isn't in the spot where the balance between the different room modes is as even as it can be. That is my what's the word? What is my assumption? Let's just say it like that. I assume that's what's going on. Yeah. So if you want to get consistent subwoofer level, you need to change your listening position. You need to find the spot in your room that gives you the most balanced low end in terms of standing wave balance. I call that the low end sweet spot. There are usually 1 or 2 spots in every room where you can get that. Yeah. And you need to test your room to find the low end sweet spot. And that's where you need to place your listening position. And then you are prepared for a subwoofer. Because now, no matter which room mode standing wave that is triggered by the subwoofer, it will deliver a reasonable amount of energy to you at the listening position. Yeah. And again, if you want to check that out, I developed a test called the Bass Hunter technique. It's one of the first things that I kind of came up with when I first started Acoustics Insider to help people with this exact problem. It is to find the spot in your room that gives you the low end sweet spot, and then to build your listening setup around that spot, because that is the only way you can get a consistent low end in a small room. Yeah. If you just Google the Bass Hunter technique, or if you go to my website and you sign up to the free Phantom Speaker test, that will walk you through it. I will show you exactly how to do it. Let's see what else we got. Adobslaw says, hello, Jesco. Good to see you, man. Thanks for your guidance and professionality. Do you have experience with Dirac versus Sonarworks? I do not have much experience with that. I don't believe, did I ever test Dirac? I don't think so. I have some experience with Sonarworks, but to be honest, it doesn't matter. Yeah. The important thing is, what do you do with it? And how is it part of your overall treatment process? Yeah, if you check out my treatment framework, you'll see that room calibrations, speaker calibration is part of that process, and I recommend that you use it. And that it's always the very last step in the process, because you want to minimize how much you have to use it. And you basically want it to take you that last mile, if you will. Yeah, you want to do all the heavy lifting through sweet spot positioning, listening position, speaker setup, acoustic treatment, and then speaker calibration. And with a little luck, if you do those first 3 steps right, you might find that you don't actually need it, even though the frequency response isn't perfect by any means, but it's good enough so that you don't need any actual speaker calibration. Yeah, and in that case, they usually don't have to work that hard anyway, and so it doesn't matter which one you use. It's usually just a matter of like some low end, some high end, and some like 2 or 3 parametric boosts or cuts. Yeah. Let's see what else we got. Martin says, I have followed your Bass Hunter guide, worked like a charm. See, great, excellent work. The frequency response proved it too. That is the best spot. Thanks for that already. Yeah, I've seen this many times, and I hear this all the time from people who actually take the time and do it properly and go through it. It is so much quicker than using measurements, and it is actually just as reliable, if not more reliable, because reading measurements is really hard. Yeah. The Bass Hunter technique is a stroke of genius, if I may say so myself. Is it perfect? No, but it works far better than I would have ever expected when I first came up with it. Yeah, so well done, Martin. All right. Let me jump back to some of the questions that were submitted. And I mean, we're just about to hit 80 minutes, or we just hit 80 minutes. I just want to see if I can find that question with the subwoofer, because I wanted to dig into that. There's a really long questions by Chris. I'm sure there's a great, but I want to see if I can find this one. Where is it? Here we go. Nico. Merry Christmas to you too, Jesco. Again, a belated Christmas to you too, Nico. So let me get to your question. My biggest questions all concern subwoofer integration, how to find the best placement and how to select the best crossover frequency for the room. Is the subwoofer crawl the best method? Excuse me. I have a hard time grasping the right intensity for specific frequencies in the very low range. It's hard to do. Can measurements be included to help out? Should I set a different low-pass filter and do a crawl for each? Since the low frequencies are harder to treat, should I adjust the listening position based on the subwoofer position, then figure out the speakers and the phantom center later? Many thanks for your help and excellent courses. All the best, Nico. Great question, Nico. And so maybe you already got a hint to it on it. How do you say that? From what I just said. But you want to find your listening position first, because that sets you up for a proper subwoofer integration. Yeah, because you need to find the spot in your room that gives you that balanced low end in terms of standing waves kind of coming together. And that will then allow the subwoofer to work properly. Okay, so listening position first. Once that is set, we can think about subwoofer placement. So the position, the subwoofer crawl, is mainly about the frequency response of the subwoofer. Yeah. So the way to do this is that you find your listening position, then you adjust the subwoofer position to get the best frequency response, and then you set the crossover. Yeah. So it's in that order. And it is hard to do by ear. Let me just say it like that. Yeah. If you want more details on this, remember I did that series with Head Audio a while back, and there's 2 videos on subs in that, and that'll tell you a lot more about what I'm about to say. Yeah. But it's very hard to do by ear, because you need to optimize the frequency response, but more importantly, you need to get a matching phase response between your speakers and your subwoofer in the crossover region. And unless you have matching speakers and subwoofers from the same company that are meant to work together, chances are they will not match. And funnily enough, it's pretty hard to, unless you can adjust the phase response of either continuously, you cannot match the subwoofer with the speakers properly if they're not meant to go together. It's one of the big questions, in my opinion, on why studio subwoofers don't have a variable phase response. Because you literally, forget about this whole 180-degree flip thing. That is somewhat useful, but that's not what I'm talking about. And unless you can adjust the phase of either, you literally cannot match them properly. And it's crazy that they've been doing this in proper sound system design for I don't know how long. And us studio guys we're just now getting subwoofers where you can adjust the phase. Yeah, it's a bit ridiculous. But so, coming back to your question, the subwoofer crawl is the best method if you don't use measurements. Yeah, and the only way, unfortunately, is, to date, to do it properly, like technically correct, is to use measurements, because you can't really match the phase response by ear. I have, well, it's a different story. I've had this idea of how you could potentially do it, but it's not fleshed out yet. And so you want to do the subwoofer crawl, even if it's hard. Remember that you have to put the sub at listening height. So you need to put it on the chair, on a bar stool, so it's at the height of your ears, of your head, and then you do the crawl. And if you don't have proper low end control in your studio, it can be really hard. Yeah. The next thing you want to do is to at least get a chance of getting the phase matching right, is to have the sub basically at the same distance to your ear as the speakers. So that means the distance from your ears to your speakers becomes the radius of a sphere, and where the sphere intersects with the floor is the line on which you test your subwoofer crawl, right? Because that means no matter which of those positions you pick, hopefully the phase response will match. Yeah. Then you want to test in the right order the positions. So because you can locate if a subwoofer is to the side, yeah, don't come to me with this whole you can't judge low frequencies location. Yeah, it's true in theory, except that a subwoofer doesn't just play low frequencies. So you can hear where it is. So you want to, if you use a single subwoofer, basically place it in the middle between your speakers at the right distance. If that doesn't work in terms of frequency response, then you start moving it to one side or the other to see if you can get a spot where you can get a better frequency response. And then that should hopefully give you a spot where the frequency response is right and the phase matches. And if you're doing this with a subwoofer from a different brand than your speakers, all bets are off. Then you need to use measurements. Yeah, and that's a whole other bag of mumbo jumbo. Yeah, again, something that I hopefully will get to at some point, doing a course on subwoofer integration, using measurements to do this properly. You can do that with Open Sound Meter, which I mentioned at the beginning. But yeah, apart from that, the subwoofer crawl for now is probably still your best bet. Yeah, check those videos out that I did with Head. Yeah, they're very detailed and will walk you through a lot more, hopefully explain a lot more what I just said. But a course with measurements would be amazing. It would. It's on my to-do list. It's literally, I mean, I've started sketching it out already. It's like, my to-do lists are like kilometers long. You have to understand, yeah? There's so much I could cover. It's literally a matter of just organizing yourself properly to get to actually doing it. Yeah, and I want to have a life as well. Yeah, something that unfortunately gets forgotten often, but I don't want to just work, you know. So what are solutions for the first floor reflection? There are none. And you don't need it either. Yeah, the floor bounce doesn't matter. Forget about it. Floor bounce doesn't matter. You're welcome, Nico. Enjoy the holidays as well. I'm going to go for another like 10 minutes or so. Yeah. So unfortunately, too many questions here in the that were submitted before. I won't be able to get to all of them. I'm just going to look at the chat one more time. Again, awesome to see all you guys here and joining me for this little session between the years. I'm just scrolling up in the chat to see if there's... Mole M said, hi, Jesco. Lots of people, including some prevalent YouTubers, say you cannot boost a null. I measured my room with REW with the output set to sound ID, and it halved my 10 dB 90 hertz null. What's your take? This is a question between practice and theory. Yeah. In theory, a room mode null can't be EQ'd because a room mode null is a cancellation null. A cancellation happens because the energy is confronted with its inverse image, its inverse version, and they cancel each other out. So if you try and boost it, you put more energy into it, you're just boosting both the version going one way and the reverse version coming the other way, and they still cancel each other out. Yeah. So in theory, you cannot boost a room mode null. And if you ever actually have a pure room mode null and you try and boost it, you'll see that happen if you actually manage to target it properly. Yeah. So maybe just about a while ago, I talked about actually figuring out what frequency that null is at is a question of its own, because measurements are inherently inaccurate, yeah, because of windowing. Yeah, so there's some frequency. What's the word? Basically, inaccuracies due to the fact that you have to window your response. Doesn't matter. Point is, you might measure the room mode to be at 90 hertz, but it's actually at 85. Yeah, and then obviously if you try and boost 90 hertz, the 85 hertz where it actually sits is like, I don't care. Yeah, so that's another problem. That said, in practice, you often have effects sitting on top of each other. So you might think that it's just a room mode null, but it's not. So there might be a part of a comb filter that is sitting right exactly on the same spot. And you can boost that. So you're boosting the comb filter null and at the same time boosting the room mode null. And that's when you start seeing effects. Yeah. So what was my take? Try it. And if it doesn't work, chances are you're trying to boost a pure room mode. If it does work, great. Moving on, right? See why I'm good. I mean, a lot of this, you don't have to get too obsessed about like people arguing about theory, right? Just try it. If it works, great. Then who cares if whatever somebody says, you know? But it obviously makes sense to have an understanding to see when to be able to judge when it doesn't work. Why, right? Let's see what else we got. Hellfire Yoga, thanks for all the good info as always. Absolutely. Commenting, any chance you could comment on the density and the suitability for hanging panels? You need a bit of rigidity to avoid sagging, etc. Yeah, several things you can do. So obviously, first thing you can do is you can not have the sagging bit touch the visual barrier, right? So build a frame, put some fabric on top that the insulation material sits on, and then put another layer of fabric underneath. So there's a bit of a gap. The visual part isn't the same as the actual physical barrier. You don't need to use fabric. You could use something else, chicken wire. You could use just strips of fabric. Yeah, many things you can do. Let's see what else we got. Whoa, and the chat just jumped again, and now I lost where I was reading. So the question on using two subs to phase cancel the other sub. This is definitely possible, and people use even more than 2 subs on occasion. There's a couple of kind of prerequisites for this to work. So the response of the room needs to be very symmetrical, yeah, because obviously you're trying to cancel the energy from one sub with the energy from the other sub, and so it needs to. You need to kind of basically do the same as room mode cancellations, room mode nulls, but through the energy with the sub. And so the responses of the two need to mirror each other. And if your room is asymmetrical in terms of the response, the low end response, it's actually it can be pretty hard to do. Yeah, there is the obvious financial question: subs aren't cheap. There is the fact that you're using a lot of energy from your sub to get rid of the same amount of energy from the other sub. So you're basically using a lot of energy to get nothing. So it's not really correct, but like headroom is the point I'm getting at, is you're taking headroom from your subs because obviously that energy can't be used to play energy into the room. Yeah, so you need a lot of sub. Yeah, do you need that to get your mixes to translate? I mean, it becomes a question of just taste and priorities. Yeah. Do you want the best of the best? Yes. Then do multiple subs. Then get a Northwood room. Yeah. But if you're treating your home studio, do you need multiple subs? No. Should you get a sub? Yeah, probably. Should you do some proper bass treatment? Yeah, probably. Yeah. So it's kind of like where on the ladder from noob buying foam to I'm paying Northwood Acoustics $200,000 to build a studio. Yeah, where on that ladder are you? Yeah, and you need to kind of decide that for yourself. Yeah? For the people, for what I'm aiming at, you don't need multiple subs. Yeah, you definitely don't need multiple subs to mix a hit record. Yeah. All right. Got another 5 minutes or so. Martin, you said if I run out of questions, you started a 4-minute message split question. I wish I had the time to go through it and put it together. All right. Finn asks, how much does a Northwood room cost anyway? Apparently, it's cheaper than you think. Yeah, but it's definitely not cheap. Yeah. Finn says, should you not care about the floor bounce, even if it tears a hole in my frequency response? Yes. You should not care. Yeah. You got to understand that how we hear psychoacoustics is not the same as measurement data. Yeah. As far as I understand, there's some research that shows that you actually need a floor reflection to tell proper left-right localization, because that's how our hearing works. So if you want a proper stereo soundstage, you might actually need the floor reflection. Also, it's one of the last things that remains. Yeah, there's a video I did a while back on some of was it called the 3 effects that you will never get rid of, or something like that. Yeah, for example, one of those things where, or this idea that you can treat a room enough so that you can then walk around the room and the bass won't change. It's a myth. Not because you can't damp room modes properly, fully even, but you always have 2 speakers. And if both speakers play low end and you change the distance relationship from one speaker to the other, you will get a comb filter. And so as you're moving around, your low end will change. Even if you put two speakers out in a field and you listen to low end and you move left to right, your low end will change because you're using multiple speakers. Yeah. Martin, so you posted that question one more time, so let me just check it again. We exchanged a big desk for a smaller one. Would you move your listening position or speaker position first after successful bass hunter technique verified the listening spot? I'm not entirely sure what your question is. Would you move the listening position or speaker position first? So you nail down the listening position, and that does not change, period. Yeah, no matter what you do with your speakers. Yeah, because the listening position is dependent on the room and not where the speakers are. So once you found the low and sweet spot, that is where your listening position is. Done. Now you can set up your speakers to give you a proper stereo image at that same position. And you can experiment with different sizes of stereo triangle, with different angles, yeah, to give you or to change, to massage the stereo image, if you will. Move them further closer to the front wall to reduce speaker boundary effect, while hopefully still getting a proper stereo image. Yeah, but your listening position doesn't change. So you're basically scaling up the size of your stereo triangle. It's kind of like my head right here. Yeah, speakers, and you're just doing this. That's what you're doing. Speaker, my head position doesn't change. Yeah, good, got it. It's northward. Yeah, northward, towards the north. Yeah. What's my opinion on waveguides and bass traps? I don't have an opinion. I haven't tried it. I haven't experimented with it. I'd rather do stuff that I know works and works well. It works well enough. Why mess with even more stuff? Yeah. Okay. Let me maybe wrap it up there. Yeah, unless somebody wants to. Martin, unless you want to drop your four split message one more time, or was that the desk question? Was it? You're welcome, man. Yeah, the bass hunter technique is great. It's a pity that it has such a crappy name. I wish I'd given it a slightly cooler name, but hey, that's how it is. It's stuck. Okay, gotcha. Okay, excellent. So thanks for everybody for joining, and thanks for all the amazing questions. Isn't Bass Hunter an artist? Maybe. You're very, very welcome. Thanks for coming on. And it's clear to me that a lot of you are very serious about obviously getting your rooms to work for the next year as well. He makes music, yes, but artist. Just wanted to make you aware as we wrap up. Yeah, if you want to go beyond the Q&A today and obviously get a more hands-on step-by-step system for actually treating your room, I've got my Acoustic Treatment Essentials bundle on offer right now. Yeah, so if you haven't checked that out, that's my Phantom Speaker Test course, which I mentioned a couple of times, the Bass Hunter Technique, the Phantom Speaker Test, but also my Build a Better Bass Trap course, the Absorber Placement Hacks course, and the advanced module where you can get a personal review on your treatment plan, yeah, from me. Yeah, so normally this bundle is $397 US, but as a kind of end of the year bonus, I'm going to give it to you for 25% off. Yeah, so $297 US. So that offer ends December 30th. So 2 days from now, midnight Pacific time. Yeah, so if you want to, if you're interested in that, check out the link. I've dropped the link at the top of the description. Yeah, I'd love to have you there and help you go through this process with you. Yeah, so no matter what you're dealing with, if it's an odd-shaped room, if you've got rental restrictions, obviously budget restrictions, yeah, I show you exactly how to treat your room in this bundle. Yeah, so as I've made it as the least complex that I can, because I want you to have results. Yeah, and I've tried to answer all the questions to keep you from going through all the guesswork. Yeah, so it's just as it's clear and actionable steps to getting your room sounding right. Yeah, so yeah, check that out in the link description if you're interested. I'm going to stay on for another few minutes. If you have any questions about that, so drop them in the chat. But yeah, thanks again, all of you, for joining, and happy holidays. Let's make 2025 the best sounding studio year yet. Finn, that's in US dollars. So $297 US at the moment. Timo says, is there such a thing as bass traps panels being too thick? No, not really. Yeah, the funny thing is, if you want porous absorption to work down to 20 hertz, you literally have to make it like a meter deep. Yeah, that's, thanks, May. Good 2025 to you as well. Obviously, that's hard to do, but that's, so there is no too thick to bass traps panels. There is obviously a kind of price, performance, space usage compromise, and that's kind of what I aimed at in the Better Bass Trap course as well. Yeah, to find that sweet spot where you're getting the most performance for the least amount of space with the least complexity and cost. Yeah, so kind of threading that needle is what that course is all about. Yeah, so I don't think you need to go totally crazy in terms of panel depth. But yeah, technically you can't make a panel deep enough. Janice, you said, please doesn't mean if you have to side walls very close, let's say 2.15 meters, the side traps must be bigger. Well, I'm not entirely sure I understand your question. Maybe you can just rephrase that for me. Well, not sure if you got that. I need to check out Bass Hunter, the artist, Finn, huh? I'm going to do that once we're off. I immediately had to think of Shapeshifter. I think I got in touch with them, or they got in touch with me, actually, not too long ago. One of them did. I do have to know him. I named an acoustic technique after you. It's about optimizing your bass. He made Dota. Okay, I'll check that out. Okay, and let me get to this one more question here. I have a dip between 800 to 1,000 hertz at my listening position. It's always when I want to mix vocals, I can hear a phase shift. And my sweet spot is really small. Do you have any tip? I mean, 800 to 1,000 hertz is pretty high up. Typically, if you have something going on in that frequency range, it's probably part of the desk reflection. And I'm not entirely sure what you mean by phase shift. You got to remember that a phase question always involves two signals. Yeah. So you can't have phase on its own. Yeah. You can have a phase difference between two things. Yeah. And so if you say that you have a phase, you can have hear a phase shift. Maybe you mean that you can hear some sort of comb filtering. Is that what you mean? Yeah. But it's, yeah, if it's 800 to 1000 hertz, very likely that it is something to do with the desk. So that's what I would look at. Yeah. Simple enough to just throw like a thick blanket over your desk. And yeah, so it's comforting. It's simple enough to just throw a big blanket over your desk and see if that reduces the effect. Yeah? Give that a shot. Sure thing, Felix. Appreciate you coming on. Teenagers do have just a phase. They have many phases. They have phase issues, that's for sure. All right, guys, I'm going to call it. Yeah, good chatting to you, all of you. Yeah, good having you on. And to 2025, yeah, let's make it happen. See you on the channel. Obviously, in the comments and stuff, on the website, in the courses. Again, if you want that, you want to check that out. Acoustic Treatment Essentials on offer right now. So check that out. But yeah, good hanging out with all of you. All the best. Have a good New Year's. And see you in the first vid in the New Year's. Sven, you're very late. Still, good 2025 to you. All the best. Bye-bye.